Hello, mate, and welcome to Let's Code Season 6, Episode 21, if you can believe it, and we're still going strong. In this episode, we're going to look at starting to get our mobs, our enemies, to move around the screen, and we're probably going to bleed over into a second episode because there's probably going to be some debugging to do in the pathfinding algorithm. I'm willing to bet that more than one of you is having issues with that, so we will look into that in an episode after this one. So let's jump into today's code, shall we? So what we've got here is a new method. This is going to go in the room class down at the bottom. And as you can see, it's called move entity path. And all we do is take the entity in as an argument. And then we call our A star pathfinding method by using new root equals A star. And then we pass into it the get matrix for the room. In other words, the room's matrix, the position of the object that we want to move, and then the place where we want it to go, which are those two arguments at the back end of that. And then we're going to say if length of the new root is greater than 2, in other words, if we have more than 2 positions in it, then we're going to set the new position to be the second position in that list, new root 1, and then we're going to move our entity to the new position. In terms of AI, we need to add another thing here. So what I've done is I've actually added a new variable or a new field to our entity class constructor. This is the enemy. So what I've done is I've taken the goblin that we had previously and I've just renamed it to enemy, and I've added an aggression variable to the constructor. And then all I'm doing is I'm setting the attack priority to the aggression in that. So that's all I've changed in the enemy class there, or the goblin class. You can leave it called goblin if you want to. Just remember that that's what I've done, so you don't get confused when we get to the next bit. And then we've got a new property in our entity or our enemy class that just says get escape priority. And then this formula is 5 minus 4 times the percentage. So all we're doing is we're saying that the escape priority has a minimum of 1 and a maximum of 5. Because once the hit points get down really low, then the 4 times hit points divided by get max HP is going to be a very, very low number indeed. So 5 minus a very, very low number is closer to 5 than 5 minus 4 times a very, very large number, isn't it? So there you go. So that's just giving us a increasing escape priority depending on what the hit points of this mob is. That's all that formula does there, because it basically means that we can now set the threshold at which the mob will change its mind about going after the player, and it'll start trying to run away instead, using the waypoint formulas that we created a few episodes ago. And our get escape waypoint method here, as you can see, we take in the room as a parameter, and then we set the output position currently as 0, 0, because we're going to change those things. We want to make sure it's a tuple. And then we're saying if the object position is 0, if the X position is greater than the player's position X, that's what player position 0 means. So if we're to the right of the player, then we're going to set our X position for our escape waypoint to be the very, very right hand of the screen. If we're to the left of the player, then we're going to set it to be 0. And then we apply the same logic to the Y position. So basically we're just going to, if our character, or if our mob in this case, is going to make a break for escaping, it's going to run to the furthest corner away, or from where the player is basically. It's not foolproof. There are situations where if the player is at position 19 and the NPC or the enemy is at position 20 and it's only a 20 size grid, it's just going to probably get stuck in a corner, but that's fine. It just means that you can shepherd the mobs into a corner if you're very, very clever about it. You know, it's up to you how you design your game rooms. If you make them so with sufficient obstacles that it's impossible for the player to manipulate the mobs that way or not. This is not a super, super complicated way of doing it. There's obviously more sensible things that we can do. We could put in a formula that just simply finds the furthest square away from the player in the room that's not directly on the other side of the player, and the mob can run around it or whatever. But we're just going to keep it super simple. If you want to go super deep into the math and figuring that stuff out, that's entirely your prerogative, of course. And then this bit of code is another method that we're going to put inside the player class, or sorry, the entity class. And what we're doing here is we're just basically saying return the position of the player if the attack priority is attack. If it's not attack, then we're going to get it to use the escape waypoint instead. This is just literally a method that puts out a position depending on whether this mob is attacking or retreating. So this method goes into the entity class as well. Sorry, got my models worded up there. Goes into the entity class, and it's just the move with the capital M, and then we put in the room as the argument, and then we're just going to call the room's move entity path method that we created at the start of this video. So it'll just call that method, and then the pass there, you don't really need it. I just had it there as placeholder for something else, but you can put that in or not. It's entirely up to you. So this is all we're doing. This is the move of the entity class. The method in the entity class called move just calls the move entity path method from in the room class. Now within the room, we need to add our update method, or rather add code to our update method, because we should already have one. And all we're going to do is we're going to say for item in self.getAllObjects, try item.update, except pass. Basically what we're saying here is we're going to go through everything that's in the room, in the matrix of the room, and we're going to try to call its update method. If it has an update method, it'll do something. If it hasn't got an update method, it'll throw an exception. But in this case, we've caught the exception and we're just saying do nothing. That's all we're doing here. So this will work. It won't throw up an error. It'll just sit there fat, dumb and happy, doing very little indeed. And then inside the game class, we had a method called update. And inside the game's update method, we're going to put in self.currentRoom.update. So this is the method that calls the room's update method, so that the game class is still in control of when things update. So the game class will say, hey, current room, do an update. It will then call the room's current update method, which the current room's update method has that thing where it loops through all of the objects in the room and tells them to update, and they will do their various bits and pieces. So in the case of our entity class, it will call its move method if it can move, and then it will do whatever it needs to do. Now the last bit that we need to do is add to our Ren'Py code inside of our start method, where we've got our game loop. We need to add game.update actually into the game loop so that it does call the update. What will happen is that when we move the plays and WAS and D keys, it will do nothing. But when we hit the next button that we added to our main UI, that will actually cause our UI return method, or our UI return declaration here, to actually return a value, which will then cause the game update method to be called just once. Then it'll loop back around and it'll go back to the UI return statement and wait for us to interact with the UI again. So moving the player does not count as an interaction with the UI, but clicking on the next button does. So assuming that you've implemented everything more or less correctly, what should happen when you run this code is that when you hit the next button, you will see the player, or rather the enemies on the screen, starting to move towards the player. But in order to do that, you obviously need to create a new entity or a new enemy object from within the game class and actually put it into the current room. So you will need to remember to do that, otherwise you're not going to notice anything. But we'll talk more about that in the next video. I'm keeping this one short because we've done a couple of longer videos recently where people might be struggling to keep up. So we did the recap last episode. The next episode, I'm going to be talking about debugging our Pathfinder and the code that we feed into it and that we get out of it to make sure that it's actually working correctly, because it's very easy to screw it up if you make a typo, or if you put some of the code in the wrong order, things may not work as intended, and you might end up with either infinite loops, which just cause the game to hang, or the entities not moving, or all kinds of stuff like that. Okay, so hopefully you got something useful from this episode. I will see you in the next one. Let me know what you think in the comments below. But until then, you take damn good care of yourselves, all right? Bye-bye.